For 40 nerve-wracking years, the world lingered on the brink of nuclear annihilation. It was called the Cold War, a constant game of military and political one-upmanship between the communist-dominated Soviet Union and the United States. All-out nuclear war wasn't just a threat. It could wipe out human civilization at any moment. The two superpowers engage in a secretive battle of underwater titans. Bigger is better, especially when it comes to nuclear missile-carrying submarines. And Russia commands the biggest, longer than a football field, with 2 nuclear reactors churning out more than 100,000 horsepower of thrust. Able to dive for months, each submarine carries more than a dozen nuclear missiles, enough to annihilate the United States several times over. But living underwater poses threats to more than just the enemy. Should the sub's nuclear reactor melt down, there's little chance of escape. In this deadly standoff, nuclear submarines are the strategic asset. Stealth is everything, a game of cat and mouse, to track and eliminate enemy subs before they eliminate you. By the 1980s, at the height of the Cold War, the US and Russia are in full preparation for the day no one ever wants to dawn. It's the possibility of mutual annihilation that ensures peace and deters war. Cold War logic that possessing such deadly power is itself insurance against ever unleashing it.
Nuclear-powered missile submarines became a key part of Western and Soviet deterrence.
Few Americans know Russian subs better than naval historian Norman Polmar.
You could never find and destroy all the nuclear missile subs. This couldn't be done on either side. Hence, they became the reserve, the strategic reserve, what both countries called the deterrent factor.
The Soviet Empire's nuclear arsenal was concentrated in the far north, the Kola Peninsula, a landmass reaching out into the Barents Sea. Nowhere else on Earth has a greater concentration of nuclear material, and at its center, the world's northernmost city, Murmansk. 2 degrees north of the Arctic Circle, a hotbed of the Cold War. In the fjords flooded by the Barents Sea, the warm waters of the Atlantic current never freeze. It's the perfect hideout. Anchored here around Russia's most important top-secret nuclear submarine bases are the pride of the Navy, its mobile nuclear deterrence. But overnight, the mighty Soviet Union suffers a financial meltdown.
Mr. Gorbachev, open this gate.
The fall of the Berlin Wall marks the end of the Cold War.
With the end of the Cold War and the financial situation, suddenly the military were starved for funds. Of course, that included the Navy. The Navy suddenly found they could not keep ships in commission, could not keep submarines in commission, could not keep their personnel, the numbers they needed. So the Navy, to some degree, fell apart.
The chaos of the 1990s still reverberates here today. These Arctic fjords, the arteries of the Soviet Navy, are clogged with shipwrecks. Rusty reminders of a long-gone era. Former legends, now environmental liabilities. It is a place still surrounded by secrecy, and with good reason. These are the reactors of Soviet nuclear super subs, able to generate 190 megawatts each. enough to accelerate a 10,000-ton sub to a cruising speed of 50 miles an hour, underwater. Now they are separated from their bodies, but still alarmingly radioactive, threatening an environmental nightmare and the perfect ingredient for a terrorist dirty bomb.
I think that took years for the magnitude of the problem to sink in and their lack of ability to handle it. In 1990, no one in the Soviet Navy expected in the next year to begin decommissioning 100 nuclear submarines. The thought just never occurred to them. So it's taken time to realize we had to help because it was a problem that didn't affect just the Russian people, but the whole world.
Murmansk, the epicenter of this nuclear nightmare, is one of the most forbidding places on the planet. During winter, in the eternal Arctic night, temperatures drop to more than 40 degrees below zero. Such harsh weather is a huge impediment to cleaning up the nuclear heritage of the Cold War. But in fact, it is just one of several major obstacles for the team of uniquely skilled German engineers tasked with this monumental job and led by Detlef Mitan.
We are operating in a high-security area that is close to the outside world. When we began our work here, this had been a huge problem. But I think that we have built enough trust so that the Russians don't suspect us spying for military secrets. Instead, they know that we are here to get the job done.
The job: decommission over 200 nuclear submarines and icebreakers. A multi-million-dollar project, in large part accomplished by hand, a fusion of crude and clever. These former East German engineers spent half their lives within the Soviet Empire. They know the language, the customs. The Germans bring unique engineering know-how, while the Russian contractors put ideas into practice. And here, man cannot touch everything.
Scrapping a nuclear sub presents two fundamental problems. First, we have to see the reactor compartment and find a way to store it. And second, we have to safely store all the radioactive material that accumulates during the scrapping process.
A submarine, in essence, is nothing more than a submerged tube of steel. Large parts can be recycled, even resold. Welding through thousands of tons of steel is simply a question of labor. The size of the job doesn't worry Mitan's team, but something else does, something invisible to our senses, emanating from these reactor compartments: radioactivity. Cutting the reactor out of a nuclear sub isn't the challenge. Tightly sealed, the compartment even floats. But floating nearly 200 of these reactor compartments is no way to store radioactive material. What if they leak, or sink, or even worse, fall into terrorist hands? For Mitan and the world, time is ticking. At the height of the Cold War, Russian subs carried enough warheads to wipe out whole parts of the U.S. Today, these largest submarines ever built are nothing more than radioactive junk. Scrapping a nuclear sub requires a unique set of skills. A team of German and Russian engineers has taken on this monumental job. At this nuclear power plant in northern Germany, on the fringe of the former communist empire, the world's biggest decommissioning effort has been underway since 1995. Here, Detlef Mitan and his company have learned how to handle the force hidden behind walls of concrete and steel, the nuclear reactor, a source of unimaginable power and radioactivity. These are the highly contaminated parts of 5 Russian-style nuclear power plants. They emit so much radiation, decades must pass before they can be disassembled. A job that will extend beyond Meton's lifetime.
Actually, our philosophy here, as in Russia, was to hand over something later generations could work with.
Meton's unique communist-era knowledge of Russian reactor design is a dying art.
We must solve the problem now. What we pass on can then be safely finished by future generations.
Back in Russia, winter's stark, snowy darkness has given way to lush green and sunshine during the brief Arctic summer. Meton and his team head back to outer Murmansk's Dnieper shipyard in the high-security military zone. There's a ton of work ahead, literally. This is a nuclear-powered Victor-class submarine built to hunt and destroy U.S. subs. Today, these 2 men are its chief undertakers, Meton and Rostislav Rimdyonov, his Russian engineer colleague. Before any work can begin, there is a step so top secret, even these men are not allowed to witness it.
The first really delicate steps are disarming the sub and defueling the reactors. This has been done.
Next, the team will work around the reactor compartment, handling lots of radioactive material.
Of course, the radiation protection team is monitoring very closely so that no contamination occurs.
This submarine had 2 layers of pressure-resistant hulls. Both have been cut open, revealing the tangle of steel, pipes, and cables in the stern section of the sub next to the reactor. But blowtorching this steel hulk apart brings the constant risk of fire. If not immediately dealt with, radioactive ash can poison the workers. The plan is to scrap this submarine from both ends, steadily working towards the center, the compartment housing the reactor. It emits so much radiation that simply cutting it into pieces would be suicidal. Handling the highly radioactive core of a nuclear submarine presents the greatest engineering challenge.
Without question, it is absolutely much more difficult to break down a nuclear-powered submarine than it is to build one. It's the fact that you have all that radiation. The radiation in the beginning of the nuclear reactor process is pretty negligible compared to the radiation that you have with all of the radioactive waste that was generated during its operation.
This is why the engineers have come up with an ingenious idea. The submarine is dismantled so that only the compartment housing the reactor and the 2 neighboring compartments remain. The sub's pressure hull is turned into a container with enough room for all the contaminated material. The closed bulkheads at each end act as a seal. Nearly 200 of these nuclear submarines have been reduced to such 3-section units. There is enough air trapped inside for these several hundred-ton reactors to float. But this is no long-term solution. It is just a first step to secure the compartments within a small area. The reactors of an entire nuclear fleet need a final resting site. Decades must pass for their radioactivity to decay.
When it comes to the factors that would govern how safe or unsafe the dismantlement process is, it would probably be safe to say that it's a function of the space that's available, because you have to have a place to store this material, there's no question. The facilities that are available, you know, how safe and how radiation-proof, if you will, are the facilities, and the security that's available.
There is no alternative. These 1,600-ton units must be lifted out of the water and further reduced so that only the reactor remains. The bulk of radioactive material is concentrated at the bottom, so a sheet of concrete and lead is attached as a shield. This is all that remains of Red October, ready to join the other subs at their final resting site some 20 miles by sea from the shipyard. Here inside a bay, the reactors are stored on a concrete foundation 3 feet high so that no radioactivity can escape. But the job doesn't end there. Next steps hope to decontaminate any radioactive material once attached to the reactors. Valuable know-how gained in Eastern Germany. Another high-security zone few can visit. Sandblasting off radioactivity can often make components safe for recycling or using chemicals. 60% phosphoric acid dissolves sheets of contamination. It's labor-intensive. Each radioactive part needs special attention to salvage and recycle as much as possible. Sida Bay will become the autopsy lab for radioactive carcasses and the graveyard for Red October. Back at the Dnieper shipyard, dock workers are still gutting the colossal Victor-class submarine. These men will be the last to remember its might before it's reduced to mere heaps of junk. The sub is history. Few will remember its role, because even in death, Russia avoids talk of its nuclear fleet.
Well, the Russians surely won't tell us where this sub was operating or what its role was. It surely roamed the world's oceans for more than 2 decades. Now its last voyage is to the storage site.
This is the death of a Victor-class sub. But naval historian Norman Polmar has access to Cold War intelligence about its birth.
This is a Victor-class nuclear submarine that was just partially completed in St. Petersburg, then Leningrad. It's launched into a floating dry dock covered with camouflage netting so that U.S. surveillance satellites can't identify features of it. The dry dock will then be towed to the Kola Peninsula to be completed. Again, just really impressive the way the Soviets handled this.
Russia's atomic fleet is disappearing fast. In less than 2 decades, the last nuclear submarine and its reactor will be dismantled, including the reactor of Russia's most famous sub, whose disaster would ultimately sink the entire Russian Navy. It's summer of the year 2000. After a decade of political chaos and economic meltdown, Russia, once again, is flexing its muscles. With the Northern Fleet's biggest maneuver since the collapse of the Soviet Empire, Russia is back. And with it, the world's most modern, gigantic, unsinkable nuclear sub, the Kursk. Built post-USSR, it is the most expensive, most advanced nuclear sub Russia has ever designed. These are rare images from inside the Kursk. Captain Lieutenant Dmitry Kolesnikov takes his wife Olga on board. The sub is so big, it even houses leisure facilities for its sailors. Dmitry Kolesnikov is proud to serve on the Kursk, although his service earns him a mere $1,000 a year. He and 117 sailors are on board during the maneuver in August 2000. They are closely watched, not only by the Russian Navy command, but also by their fiercest enemy.
U.S. Navy was monitoring the exercise. We had 1, possibly 2 nuclear submarines in the area. At the same time, the Soviets had a ballistic missile sub that they were trying to sneak out of the area without us following it. So there was a lot going on, you could say, behind the scenes, or more accurately, underwater, than met the eye.
The Kursk's mission was to show that its torpedoes can be fired with deadly precision, that destroying a U.S. aircraft carrier takes only a matter of minutes. At around 8 a.m., technicians in the bow section of the Kursk start loading torpedoes. For any submarine, its own torpedoes are its greatest danger. They contain an extremely explosive fuel. If not handled with care, they are bound to explode. What the Kursk sailors did not know is that their torpedoes hadn't been maintained properly. At 8:51 a.m., the signal, ready for torpedo firing, is the last message sent from the Kursk. There are 2 explosions of such magnitude that they are registered in Alaska, 3,000 miles away. A truly seismic event, the Kursk to the bottom of the Barents Sea.
Well, what was planned in the naval exercise is a major demonstration that the Russian Navy was still on the map, that Russia was still a great military international power, turns just totally around with a major disaster.
Surprisingly, the Russian Navy does not make much of the explosion. Only at the end of the day, after failing to contact the Kursk, do naval officers begin to worry. Hours are lost in search of the stricken sub. After all, the Kursk was built to be undetectable. Then, a sonar echo in shallow waters. The Kursk lies at a depth of only 300 feet. Divers could quite easily reach it. But the Russians' rescue equipment is so old and badly maintained, it cannot make contact with the Kursk. If there are survivors, every minute counts. But the Navy refuses to admit defeat and firmly rejects foreign help.
The Soviets in general were able to bring their damaged submarines up to the surface, and most of the people were able to get off. The major exception was the Kursk, and that was because of the type of damage where a torpedo had exploded in the bow and just blown the whole bow section off.
Running out of options, the situation escalates. The authorities try to silence angry wives and mothers with very dubious methods indeed. It takes the president to intervene. The Russian military is still split whether to accept foreign assistance. Vladimir Putin's still young presidency is threatened by the crisis. There are rumors that some of the sailors are still alive. Putin now wants help from abroad. Almost a full week after the Kursk was lost, divers from Norway are able to reach the submarine. Everyone is shocked by the scale of the damage to the sub. The whole bow section is destroyed. But in the stern, there is little destruction. There could be still some sailors alive. Maybe they are even strong enough to respond. Divers are banging on the hull, eagerly awaiting a response from the sailors inside. Captain Lieutenant Dmitry Kolesnikov and 22 other sailors did indeed survive the initial blast. We know this because he left a message saying they had little hope. The sailors were alive at least 24 hours after the explosion, and possibly much longer. But by the time the divers make contact with the Kursk, there is nothing but silence. Dmitry Kolesnikov, along with 117 sailors, are dead. When the escape hatch is opened, a last gulp of air, marks the end of all hope. This coffin of steel at the bottom of the Barents Sea is a tragedy for the entire nation.
The irony of the Kursk being lost during a major exercise is that the Russian Navy was trying to demonstrate to the Russian leadership how powerful it still was. And here, the second largest type of submarine in the world suffers an internal disaster which kills the entire crew, 118 men. And because it was drawn out with some people alive in the stern section of the submarine, it showed how incapable the Russian government, the Russian Navy was with handling a disaster of that type.
To save face and retrieve the bodies, Russia decides to lift the Kursk. It is the heaviest object ever to be raised from the seafloor. Inch by inch, the Kursk is raised to the surface. Over a year after the accident, the submarine, icy grave to 118 submariners, is retrieved. For the men inspecting the wreckage and retrieving the bodies, it's almost too much to bear. Fear turns into certainty. Had the Navy accepted foreign help, some of the sailors could have been rescued. This is the worst of all possible outcomes for the once proud Northern Fleet. Its flagship lost, the crew left to die at the bottom of the Barents Sea. The tragedy of the Kursk disaster still echoes across Russia today. It towers over the end of an empire's once giant nuclear age. Pride has turned into a problem, a colossal problem that now must be dealt with. This is the reactor compartment of the Kursk, another dangerously rotting carcass. It must be scrapped and prepared for its final journey, like all the other reactor compartments of Russia's nuclear fleet. This journey is the most delicate, the most dangerous step in the long end of Red October. At the shipyard, final preparations are underway for the only reactor transport this year. The workers' time frame is short. A few weeks of summer when the weather is less unforgiving and the seas are not so rough. Only a dry dock can move such precarious cargo through the fjords of the high Arctic. The Dnieper shipyard, where subs are dismantled, is some 20 miles from the Saida interim storage site. It is a treacherous route, dotted with top-secret military installations. Calm seas are absolutely crucial. If this dock sinks, these waters will forever be contaminated with highly toxic radioactive waste. Any change in weather is an invitation for disaster. Soviet nuclear subs, the invisible terror of the Cold War, are today just problematic, rotting hulks. In a monumental effort, almost 200 subs are being scrapped, their reactors sealed and prepared for a final dangerous journey. The majority of Russia's atomic subs has been reduced to this, the unit housing the highly contaminated reactor. Workers at the Dnieper shipyard in Murmansk, Russia, prepare for an extremely dangerous task, transferring these reactors over water to their final resting site some 20 miles away. This dry dock will ship 7 reactors at once. It took a year to seal them, to make the reactors safe for their final journey. These compact nuclear power plants are no ordinary cargo. Their radioactivity limits the time humans can safely spend in their vicinity. The outer steel layer of each reactor is 3 inches thick. This puts the total weight of each reactor at 1,600 tons, the equivalent of 4 jumbo jets. Moving them is a near impossible task. Even the most powerful tools, hydraulics, sometimes fail. At this stage, even the most minute problem can endanger the whole effort. For loading, tracks have been laid onto the dock. The workers are doing double shifts to be finished and ready for today's high tide. These last hours, the culmination of a year's work, are a race against time. The biggest worry is the weather. In the high Arctic, nothing is more unpredictable. It is a factor that rules the decision makers, Detlef Mitan and his Russian engineering colleague, Lada Gajuchenko. They cannot ignore a bitter fact. The weather has started to turn against them.
We have seen today how rapidly the weather can change here. It got very windy, and that is a big danger for the transport. Movement is only permitted to a certain wind force.
They have now reached a critical point. If the wind doesn't subside, the transport won't happen today.
As you can see, the dock has a huge area where the wind can attack. This and the waves out in the fjords will prevent us from transporting the dock safely.
A disaster. It has also started to rain. But the workers carry on anyway to finish their job and hope for better weather. Massive steel buttresses will keep the reactors in place, 3 on each side of every single unit. The buttresses are welded onto the dock. But even these structures will start to crack if the sea is not totally calm. The dock workers are racing to meet their deadline. There are only a few hours left before the tide comes in. But still, the wind hasn't subsided. The sky's not cleared. Tugboats will pull the floating dock. The Russians' machines are often in a dire state. Detlef Mitan's company has bought tugboats abroad. He's also supervised the modernizing of local ones. It will be his responsibility that the tugboat's diesels won't fail. But the decision about today's transport lies with the Russians. More tugboats are called in. The transport will happen. It will take 7 tugboats to transport this dock, 2 to pull and 5 to stabilize, to help keep the dock and its precious cargo from capsizing. This is the last chance for the contractors at the Dnieper shipyard to deliver the reactors fully sealed and ready for storage. Now, good news starts to arrive. The skies have cleared, but unless the strong winds subside, this dock and its dangerous cargo threaten an environmental disaster. The seaward transfer of 7 Russian nuclear sub-reactors is about to begin. Water is pumped out of the dock. It starts to float on the high tide. 7 powerful tugboats must push and pull the huge loaded floating dock out into the Arctic fjord. They can move only at a snail's pace. At 2 knots, it will take them almost 9 hours to their destination some 20 miles away, the storage site at Saida Bay in far North Russia. Soon, it will be impossible to turn back.
Well, you really have to know what you're doing when you're working with one decommissioned reactor, let alone multiple let alone on water, trying to transport them. That is a major engineering feat. It's one of those things where, you know, if things work out well, then you can take a sigh of relief. But if they don't go well, you know, the consequences, of course, could be, you know, pretty severe. Certainly, if you wanted to say, well, let's go ahead and try to pick them back up. Well, that might not be too easy, trying to pick a reactor up off the bottom of the sea.
But at last, the weather is on their side. Bright sun and calm seas promise safe passage for the reactors. After 9 hours, Saida is in sight. The tugboats guide the dock to the landing site. Inch by inch, the dock is moved to its destination. The dock is secured, but not its cargo. The total weight of almost 12,000 tons must now be moved off the floating dry dock and join the other 33 decommissioned sub-reactors already moved here over the last 4 years, as time slowly renders them all inert. It is up to these men to direct this final step, choosing the exact place for each to permanently rest. 1,600 tons is not something to move twice. Vazgen Ambatsumyan is the director at the Saida site and a former submarine officer. Among these reactors, there are 2 which Vazgen remembers very well. He has served on the submarines they once powered.
If I remember correctly, it was back in 1982. This was a very good submarine, very reliable. It was the best sub I ever served on. The service passed without any major disturbances.
The former submariner sees his duty in safely putting to rest what was once a menace to the Western world. The giants of the Cold War, stranded on a concrete foundation deep in the Arctic hinterlands. This is the best of all outcomes for Vazgen as much as the rest of the world.
I have the privilege of knowing several Soviet submariners, now retired, a number of Soviet, now Russian submarine designers. And these people, as individuals, are talented, dedicated, and really nice guys. So when you talk about a Soviet or a Russian submariner, you're talking about a real person that you could probably get along with great.
Because of the complexities of decommissioning a nuclear sub, reactors arrive here to Saida just once a year. It will take the remainder of these men's careers to put to rest all of Russia's once mighty northern fleet. In fact, the long story of Red October won't end for another 70 years. Only then will radioactive levels have dropped enough for the reactors to be opened, handled, and fully disassembled, an inheritance for future generations. But will these casings last that long? After decades of waiting and dangerous indecision, these nuclear sub-reactors have reached their final destination. But they cannot be fully broken down for another 70 years when their potent radioactivity has diminished. Between now and then, the burning question, are they really sealed, and will they stay that way? Today, Detlef Mitan and his team of German engineers will find out whether the Russian reactors are properly sealed, or emitting more radiation than they calculated. It is not enough to technically solve the problem to store the reactors. They also must be kept safe from terrorists, and nobody should accidentally take contamination out of this area. This is why every visitor to this high-security zone is carefully monitored. A dosimeter will register the radioactive load accumulated in Metan's body when he is inside the nuclear storage site. Metan and his Russian colleague Vazgen Ambartsumyan will limit the time they spend right next to the reactor. Otherwise, they will accumulate more than their permitted dose of radiation. But going in and going close to measure the radiation levels of each reactor is vitally important.
We have 35 microsievert per hour here. That is almost a magnitude below the permitted maximum level. It means the units are absolutely tight. Still, we should leave this area now. We should not expose ourselves unnecessarily to this level of radiation.
Nature dictates that radioactivity decreases with distance.
Here, around 100 feet distant from the reactor units, we have 170 nanosievert per hour. That's a little more than natural background radiation levels. You will find this in most parts of Europe, even without reactors. In fact, this level of radiation you will measure in any town center.
The reactors are tight. If they are properly serviced, they will remain tight for another century, when a future generation will finish this job. But they might ask about why so much effort was put into building these nuclear subs in the first place.
I believe that missile submarines on both sides did have a role in preserving the peace through deterrence, that neither side could risk going to nuclear war or pushing the other to a point where it might go to nuclear war.
These behemoths of the Cold War, able to destroy the world in seconds, now will take decades to be destroyed. But maybe these submarines fulfilled their role. Perfect killing machines, maintaining peace with the threat of mutual annihilation. This was the Cold War. Today, hopefully, just a monument, suggesting that the nuclear threat of Red October was all just practice.